Hey everybody, my name is Haroon, and the topic today is non-fungible tokens or NFTs. It's organized by the Crypto Cooperative, so please visit this website, get yourself subscribed so you hear more about our initiatives and future events. The presentation is divided into three parts. Part one is going to be just the basics around blockchains, how they work, what their key advantages are. We'll then explore the concept of tokenization and fungibility. And based on that, we'll create an understanding of what non-fungible tokens are. Part two is all about the marketplace, what the popular marketplaces in operation are, what kinds of assets are there that are typically getting tokenized as NFTs. We'll also look at opportunities for just everyday participants, right? So can we participate as investors, as entrepreneurs, creators, collectors, and so on. Part three is going to be the steps to follow to actually create an NFT and mint it on one of the popular marketplaces, and that would be Rarible.com in the example that we'll use. What we'll also do there is step through a couple of previously minted NFTs and demonstrate how the traceability of an NFT works right from the point that it's created through its entire chain of ownership. Introduction. So we've seen over the past several weeks and months that NFTs have been making the news quite a bit. You keep hearing about digital art selling for tens of millions of dollars, and you wonder what exactly is going on. Why is something that seems like just a digital file of something selling for such staggering prices? So what exactly is the market pricing here? Is it pricing a file? Is it pricing something else? So we'll try and demystify a little bit of all of that. And just overall, we'll try and improve our understanding of what NFTs are and the role that they play in this new emerging marketplace. All right, so let's jump into the basics. We'll begin by exploring what a blockchain network is. A blockchain network like Bitcoin really is a set of peer-to-peer connected computers or nodes that talk to each other. And that network enables payments between transacting parties directly without the need for a central or intermediary third party. So in our everyday lives, when we send transactions, receive payments, we're always going through some sort of a trusted source. It tends to be typically a bank or a financial institution. The supply of money that we actually use, like the rupee or dollar, is again controlled by certain central entities. On a blockchain network like Bitcoin, both the supply of the money as well as the mechanism of transfer of this money or asset between different parties is decentralized. It doesn't require a trusted third party, and it's managed by this node of peer-to-peer computers which are connected to each other on a network. And these computers aren't really owned by a specific entity or the government. They're just owned by anyone who wants to join the Bitcoin network. So you could just plug in a computer to the network, run the Bitcoin software, you become part of the network, and then you participate in the various functions that the network performs in terms of managing this exchange of value or money. Transactions on this network are stored on a shared public ledger, and a copy of that ledger is available on multiple nodes across the network. So it's pretty decentralized. And transactions are also digitally signed. Because it's a completely open sort of a ledger, there's nothing secret or hidden. The only thing that's secret is your private key, which is used to sign transactions and submit them to the network. And then the network can validate the authenticity of the transaction by just looking at public data like your public address and your signature. This network performs a few basic functions. So one of which was obviously to maintain that shared ledger, keep updating that shared ledger as transactions keep getting added. It also performs the role of validating new transactions and adding them to the blockchain. It's called a blockchain because as transactions flow into the network, they get grouped into blocks of transactions, which are linked together by a certain relationship. And we'll come back to what exactly that link is. And finally, they play a role in propagating transactions. And that's important because there's no central source to receive your transactions or to receive an authorization or a validation of the transaction. So it's important that messages and data about these transactions and blocks which are getting created is propagated throughout the network. All right, so finally, the shared ledger, as we said, is pretty much a running ledger of transactions that keep getting added to the end of the ledger. And as I said, they're also grouped into blocks of transactions, and each block of transactions gets reviewed, validated, and then added to the network. And then when new transactions come in, again, they get grouped into another block, and they're all linked together through a string of characters called a hash. It's pretty much a number. Think of a hash as a number that represents the data that's within this block. And this relationship is really such that the hash of one block is included onto the next block and goes into the input of creating the hash for the next block, and so on, right? So hash of block 35 is on block 36, the hash of block 36 is on block 37, and so on. What we'll do next is explore in a bit more detail what this hash is all about and how hashing works. And to do that, I'll be heading over to this link on the MIT website, which gives us a very visual and intuitive way of understanding how hashing works. All right, so we're now on the MIT website, and we'll explore hashing in a bit more detail. A hash really is, it looks like a string of characters that represents some underlying input data. So if I type in the character A, this is the hash of A. If I type in more characters here, you'll see that the hash keeps changing. You'll notice, though, that the hash is usually of the same length, regardless of the length of the input data. And this applies whether it's one character or if I put in all of the information on Wikipedia into this box and then create a hash of it. It'll be a different hash, but it'll still be of the same length. And a thing to note here is that even if I change one single character, the hash changes completely. So it's not a change in one character is not minor change as far as the hash is concerned. It's a completely different hash. The algorithm that's used to create this hash in Bitcoin is the SHA-256 hashing algorithm. But there are other algorithms out there that can be used for hashing. But for now, it's more about just understanding these key characteristics of what hashing is and the way it works with different types of input data. Next, we'll look at a hash in the context of a block, right? So we're really interested in a block that looks like this, which is sets of transactions linked by a hash. So this is the hash of this particular block. Assume that this is a block of transactions. And again, let me make the assumption that this line here is some transaction data. When I hit mine, you'll see that the hash changes to a value that starts with a certain number of leading zeros. So this is really a difficulty that's imposed by the Bitcoin network. And it's easier to create a hash than to create a hash that starts with a specified number of leading zeros. And this is by design. There's a reason why the Bitcoin network makes it harder to create hashes, because it's expecting you to prove that you did some minimum amount of work before you confirmed a block. And to understand how that works, we'll look at the next section, which is basically a chain of blocks. The same principle applies, right? So these are hashes. Each block has its own hash, but it looks more like this data structure, right? Which is a series of blocks linked by hashes. And you'll see that this is a series of blocks, and it's linked by this hash, right? So the hash of the first block ending in 7D9 is on the next block, and then so on and so forth, right? So the hash of the second block is on the third block, and so on. So this is a set of transactions linked by these hashes. Now, you'll also notice that it satisfies that constraint that it needs to start with a certain number of leading zeros, which means that someone has already done the work, confirmed these blocks, and they're part of, let's say, the Bitcoin network. Now, if someone tries to edit the data in one of these blocks, you'll notice that it not only breaks the hash of this block, because as we said, changing anything within the data produces a completely different hash. So when I do that, you'll notice that it's not just this block, but all the subsequent blocks end up having a different hash, and they no longer satisfy that requirement of starting with a certain number of leading zeros, which makes it kind of obvious that this is a tampered with chain. So for the network to even consider this for inclusion on the shared ledger, they would have to, the hacker or the person who's editing these transactions would have to remine all of these blocks. And we established earlier that mining these blocks with a certain number of leading zeros is much harder than just creating a hash for some set of input data. So this is going to take quite a bit of time for them to remine all of these blocks, a lot of computing effort, a lot of resources. But by the time they even do that, the rest of the network will have added even more blocks at the end of the chain, right? So because, as you recall, it's not one single computer that has this ledger. It's a shared public ledger. So there's multiple nodes that have this ledger. So if I change something here, it breaks all these hashes, and then the other nodes would have something else, right? And it sort of matches up between them, and it has this constraint of beginning with a certain number of leading zeros. So you'd instantly know that this is probably a set of incorrect blocks being submitted by some malicious actor. Now, as we also said, if they remine all of these blocks in order to make these blocks look legitimate, right, where they start with those leading zeros, that would still not work because it wouldn't be a long enough chain, right? So the rest of the network would have added even more blocks at the end. And the way the protocol works is it respects the longest chain, so the chain which had the most work put in. And that makes it really difficult for an individual actor to amass as much processing power and resources to end up not only compromising this block and remining all of it, but also remining it at a rate where they end up with the longest chain. So essentially what that shows is it's really difficult to go back and tamper with data on a blockchain once it's confirmed and you have a few blocks added at the end of it, right? You might stand a tiny shot at editing some block which doesn't have too many confirmations at the end of it. But again, even while doing that, you're up against the whole rest of the network, which has disproportionately more hashing power than you do, or computing power than you do. And that really makes it an extremely futile exercise to try and undertake. And that makes blockchains very secure. And the term that's used there is immutable, which basically means that once you put a record onto the blockchain, it pretty much becomes like a record in history, where it's really difficult for someone to go back and edit it. So it becomes a permanent record in time. So based on what we looked at about blockchains so far, there are some obvious benefits of it. One of them is obviously that it's open and transparent, because all of the data is on a shared ledger and everyone can look at it. Nothing is hidden. But at the same time, the protocol or the software that enforces the rules of the network is open source and available for everyone to sort of look at and scrutinize as well. So there's nothing hidden in terms of how that works. It's not copyrighted. It's just out there for anyone to examine and criticize. So that brings in a lot of transparency. Secondly, data on a blockchain network is traceable. So you have history of the transaction records right from the time it was first made to its whole chain of ownership across the lifetime of the transaction. They're also secure and resilient, which is what we looked at in terms of the way Bitcoin uses hashing and difficulty to make sure that it's not easy to go back and edit previously confirmed blocks. And we also said that that makes it immutable or sort of a permanent record in time, which again gives it that security and resilience. Another source of resilience is the fact that it's a distributed network. It's not just one computer that's running this or a centralized set of nodes running this. It's widely distributed geographically, and it's multiple nodes that come together to perform this function. So you can take down one or a group of those nodes, but you can't bring down the whole network because of its massively distributed nature. So with that basic understanding of blockchains and their benefits, let's look into what tokenization is. And now we're getting closer to the NFT part of this presentation. So in general, what I'm trying to express through this slide is that tokenization is pretty much everywhere. We see this in our everyday lives. A token basically is an item that represents something else. And generally it's designed in a way that can be easily held, shared, exchanged, etc. So obviously we've all been issued tokens when we put items into a locker. And what it really does is it lets you hold it easily. It lets you return it and redeem it for the belongings that you put in the locker. And you can actually transfer it to someone else if you wanted to. You could just hand it to a friend and say, can you help me get my items from the locker? Right. And similarly, you have other ways in which tokenization is pretty much prevalent in our everyday lives. So I would argue that the US dollar is at a very basic fundamental level a way of tokenizing the US economy on which the dollar operates, right? So it's if you took the whole economy and broke it into tiny bits of value and printed them on these standardized units of paper-based currency, then it makes it easier for people to hold the dollar, to exchange the dollar, and do transactions with it. And that's really, in a broad sense, a way of tokenizing the functionality of the US economy. So as you go from left to right, and we get deeper into the blockchain world, you see that similar principles apply in the context of Bitcoin, for example, right? So it's again a standardized sort of a unit of value that operates on top of the Bitcoin network, and the same could be said about the Ethereum network and any number of blockchain networks out there. One nuance here is that typically the currency like Bitcoin or Ether that runs on the Ethereum network is generally referred to as a currency, not a token. But at a very basic level, the idea is really about standardizing sort of a unit of value that can then be easily held, exchanged, traded, etc. Now, on the Ethereum network, if some of you are familiar with it, there's multiple layers at work. So there's obviously the base currency called Ether, but there's also ways of issuing fungible and non-fungible tokens, and we've not really defined that yet. So we'll come to that in a moment. But you have ways of generating different types of tokens, which sort of run at a level above the base currency, which is Ether. So normally in the blockchain parlance, you generally find people referring to these assets as tokens, and you'll see them referring to Bitcoin and Ether as currencies. However, in a very general sense, the purpose of this slide is to sort of just convey the idea of what tokenization is all about, and then we can apply it more specifically as we explore this topic in a bit more detail. So hopefully this helped understand at a high level what tokenization is. Now that we understand what tokenization is, let's explore what fungibility is. So let's say Alice and Bob each have $20 each, or let's say they have 0.001 Bitcoin each. And let's assume they exchange these assets. And what do they end up with? They pretty much end up with literally exactly the same thing. So if you compare this picture with this picture, there's no difference. And the reason why there's no difference is because, well, essentially this looks like a bit of a meaningless transaction, right? Because they're exchanging exactly the same assets. So the reason why this is sort of pointless is because tokens or assets like the dollar or Bitcoin are fungible. And what that means is that they're interchangeable, they're identical, they're not distinguishable from each other. So it doesn't really make any sense doing an exchange like this, right? So really fungibility is all about interchangeability. It's about being identical. So it doesn't really matter whether I use this $20 or this $20. I can buy $20 worth of goods or services, regardless of whether it's the $20 bill from Alice or Bob, right? So these types of assets are really fungible, and the same applies to assets like Bitcoin and so on, where one Bitcoin is just one Bitcoin. It doesn't matter which Bitcoin it is. So what we're demonstrating on the right-hand side is there are obviously certain kinds of assets which you cannot represent by using these types of tokens, right? For example, if Alice had the original Mona Lisa and Bob had, let's say, a nice sketch of Mickey Mouse, they're not the same thing. And therefore, I can't say I'm going to represent the Mona Lisa using either Bitcoin or the US dollar and so on, right? And the reason for that is that they're not interchangeable. And essentially, they're not fungible. And therefore, when you want to represent these types of assets, which are unique, which have a set of unique attributes, they have very different value, you do that by creating tokens of a special category or class, which is known as non-fungible tokens. And what's really important about these is that they're unique on the blockchain. So you can see that I've designated them by sort of unique token IDs, right? So when you mint non-fungible tokens in a blockchain that point to very individual or unique sorts of assets, you need to be able to identify this token and tell it apart from other tokens. And that's the reason why they have some sort of a unique identifier or some way of distinguishing them from any other token on the blockchain. And that's really where NFTs come into the picture. All right, so let's then take this a little bit deeper into the blockchain world and explore what this looks like in the context of Ethereum, which is one of the most popular blockchains for NFTs. So on Ethereum, these types of tokens, right, so fungible and non-fungible tokens, they can be created using standards that exist in Ethereum, right? So there's something called the ERC20 standard, which is the fungible token standard. And then there's something called the ERC 721 standard, which is the non-fungible token standard. So using the ERC20 standard, you can create a set of identical ERC20 tokens. And likewise, using the ERC 721 standard, you can create a set of unique tokens or non-fungible tokens, right? Now, there are some similarities between these token standards. Now, first of all, what is a token standard, right? So it's really a set of guidelines that says that if you create a token that you want to call ERC20 compliant, then it better satisfy some basic functions, right? So for example, you should be able to create a certain number of those tokens. You should be able to assign a name and a symbol to it. You should have the ability to check the balance of that token at a certain address, check its total supply. And there's a few other things, but obviously you should be also able to transfer tokens from one address to another, right? So I've listed some very basic kinds of functions. There might be a couple of more, but the key here is that they're trying to standardize what can and cannot be done with this particular type of token. And if you want your token to be ERC20 compliant, you'd have to make sure that all of those functions outlined in the standard are implemented as part of your token. What happens when you don't align with these standards is that there might be some issues in terms of using this token in the wider Ethereum ecosystem, right? So if you want to sort of integrate this token with other functionality or other contracts and tokens on the Ethereum network, then it needs to have these basic sets of functionalities. For example, if you missed out creating the ability to transfer the token from one holder to another, then it's no longer ERC20 compliant, because then it means you can't really send this token from one Ethereum address to another. Similar principles on the ERC721 side. So, you should be able to mint a token. But one key difference here is that your token is going to have a specific ID. So here we just specified a number of tokens because they're identical. Whereas here, when you mint the token, you actually indicate a specific token ID, which makes it globally unique on the blockchain. Now, that uniqueness is actually based on a combination of the smart contract address and the token ID, not just the token ID. So it's a combination of these two things. We'll talk in a little bit about what a smart contract is, but the key here is to understand that there is a mechanism, at least, right, of uniquely identifying these tokens on the Ethereum blockchain. So no two tokens will have the same token ID and the same contract address, which is essentially what makes them unique on the Ethereum network. And that uniqueness can be used then to associate these tokens with unique assets. For example, this painting by Beeple and this particular Crypto Kitty, which is, again, one of several unique cats on the Ethereum blockchain as part of that Crypto Kitty game that you might have heard of. Now, apart from these two standards, there's also the ERC 1155, which is a more recent standard. While this lets you create a set of, while ERC20 lets you create a set of identical tokens, and 721 lets you create unique tokens. ERC 1155 actually combines some of these functionalities and lets you create both fungible and non-fungible tokens as part of the same contract. We'll come back to what a contract is. And essentially gives you a lot more flexibility in terms of how you can create these fungible and non-fungible tokens. And you can also create multiple types of non-fungible tokens through the ERC 1155 standard. Let's come back briefly to what a smart contract is. So that essentially is a program that you can write and launch on the Ethereum blockchain, and it executes on the blockchain network. It could be literally anything. It could just be a series of steps that get executed on Ethereum, which is often regarded as a global computer. So that Ethereum network is essentially a bunch of computing nodes to which you can pass software and have it executed. And that's a software that you can write and put onto the Ethereum network really is delivered as part of what is called a smart contract. So it's essentially a program that runs on the network. And creation of tokens is also done through that program. You actually have to write a program in this language called Solidity, which where you'd specify exactly what this particular function does, how many tokens it creates, and essentially all of that is put into that software program, which is called a smart contract. So tokens in Ethereum are always generated through some type of a smart contract or program. All right, so hopefully this gives some understanding of what tokens are, what fungibility is, and the way Ethereum manages fungible and non-fungible tokens. All right, so this slide here aims to show, for example, taking the CryptoKitties game as the example that we'll use here. So these essentially are representations of unique cats on the blockchain. So it's a game called CryptoKitties where you can own cats that look like these, but they're unique, right? And that's really why it makes sense to represent them using non-fungible tokens, right? So there's only one cat on the entire Ethereum network that looks exactly like this, right? So if you pick any other cat from the CryptoKitties space, there'll be some difference or the other compared to this one, and those differences are managed using these attributes, which CryptoKitties calls cattributes. So things like the base color, the highlight color, the accent, what the mouth looks like, what the eye color is, the eye shape, and so on, right? So there's a number of different factors. And when you adjust one of these factors, it will pretty much produce a unique group of attributes, right? So some of these are hidden. So the ones which would start with P are supposed to be visible ones, and the ones which start with H are the hidden attributes, right? So if you look at this, it's about 12 different high level attributes, and within them they have 4 more types of attributes. So overall, it's a fairly large number of different types of combinations of these attributes that can be produced. So each of those unique combinations are then represented in the form of an image of a cat that looks like this. And you basically own this as a token on the blockchain. So what we're showing here is that usually the image itself is not stored as an artifact on the blockchain. It's these attributes which get stored there, right? So this dividing line shows what's on the blockchain and what's off the blockchain. So on the blockchain, you have information that uniquely identifies, let's say, a cat. So it would have a unique NFT, and that NFT would be associated with these unique characteristics, right? And what would then happen off-chain is on the CryptoKitties website, they would reference some of these attributes and then use software to then render or produce an image of a cat that's based on these input attributes. All right, so hopefully that gives some flavor in terms of how NFTs are actually used to represent digital images and digital artifacts. All right, so let's move on to part 2, which is the NFT marketplace, right? So there's, I'd say, an emerging, but definitely already very fast growing marketplace where NFTs can be bought, sold, minted, created, and this slide basically looks at what some of those popular use cases are. So currently, the most popular use of NFTs tends to be in the digital art space, but that can be extended to any form of a digital asset. So it could be artwork, which is, like I said, currently the most prevalent, most popular. But you can create an NFT using digital music. You can do it with video. You could do it with in-game assets. So often games have things like special items and weapons and things like that, which can be minted as NFTs, so that you own them and it's not really owned by the gaming company. Then you should be able to then transfer that gaming asset to a different user who's within the game. And then in general, when you extend this to digital assets, you can talk about things like text-based creative items. So it could be articles, it could be short stories, poems, etc. Right? So any digital asset which is unique and creative in nature can is very well suited to be minted as an NFT. Um, the second is a slightly unconventional example. It's not as popular, but it might gain popularity in some time. There are these crypto-based domains like .eth and .crypto. There's also .zil, which I haven't listed here, but uh, these are domains which can be again held as NFTs. So generally, the domain of a website, the domain name is held by a domain registrar. So you have a set of domain names that are available once you register one of those domains. It's owned by a domain registrar. So using these crypto-based internet domains minted as NFTs, you can then have these domain names actually held as NFTs by you rather than by a domain registrar, and that gives you complete control over these internet-based domains. This is an example of a .eth domain that I registered on the Ethereum network. So you'll see that it says Haroon.eth, and this is owned as an NFT by my Ethereum address, which is displayed here on the screen. And to this domain, I can then link a website, or I could link some sort of a resolver that points to a website. And if I create that website using the IPFS file system, which is a decentralized distributed protocol for sharing files on the internet, then I could end up creating pretty much a hack resistant as well as a censorship resilient website, because I have complete control over this domain. The domain registrar can't be approached by any entity to be asked to take my website down. And likewise, the content of the website could be hosted on IPFS. So it doesn't have to be with a centralized web hosting service, which basically makes the website resilient to tamper or to take down by censorship authorities. So that's an interesting example. Not as popular, but I just want to share one somewhat unconventional case apart from these popular creative digital assets which we read about every day. Finally, what I'm saying is that this is really an evolving space. It's very new. Before 2016 or so, NFTs weren't even around as much, right? So it's just barely a 4-year-old space. So there's a lot more that can be done here. So we just have to use our imagination and see what else we can apply NFTs to. The next couple of slides have examples of recently sold or valued NFTs which made the news. So the first one is the digital artwork called Every Days, the First 5,000 Days. It's by the artist who calls himself Beeple. This sold for $69 million, and a lot of you might have seen this in the news. So it's a collection of individual pieces of digital artwork that he did over, I think, several months, probably years, which are sort of combined into a collage, and this was minted as an NFT and recently sold for that staggering sum of money. So that was digital artwork. Another type of common NFT is collectibles. So these, again, this is called CryptoPunk, and these are sold as collectible assets. Now, this particular CryptoPunk sold for $7 million, and you'd wonder why an image of a pixelated image of something that looks like this would sell for that price. But again, there's a notion of scarcity here, because again, within this ecosystem of CryptoPunks, there's apparently only 400 or so punks that have a headband, and that makes one of these punks that have a headband relatively rare on the blockchain. So so again, buying and selling of collectibles, especially ones around which there's a notion of scarcity, is another common use case for NFTs. The third is an example that we looked at briefly earlier. So this is called CryptoKitties, which is an online game where you can buy and hold unique cats. So, like I said, no two cats are the same on this game. You can even breed cats that you own that would then create a new cat, which automatically gets registered to your name on the blockchain. So this is another popular game. I believe this rare kitty sold for 170K, and I believe it's now listed for 390K on the marketplace. And again, not all kitties, crypto kitties, have the same price valuation. So you'll find ones which you can buy and sell for $15-20, but then at the same time you'll also see ones which sell for hundreds of thousands of dollars, depending on whether they have certain rare attributes which aren't as common across the CryptoKitty sort of domain or marketplace. Right. So this slide basically provokes a thought in terms of what exactly is being bought and sold here. So is it digital files? Because I can make copies of these digital files as many as I'd like to, right? And I can share them, email them, create 1,000 copies and store them on multiple devices. So why is it that these digital artifacts are selling for such staggering prices, right? So the way I'd like to explain that is it's not this physical digital file per se that's being sold. Rather, it is sort of the idea that behind this art, as well as the notion of scarcity behind the creation of this art that is being sold as NFTs here. So what that really means is when Beeple sells this artwork, he's not really selling you one copy of millions of copies of this file that he has. What he's actually selling you is an authorized token. What that means is when you go to the blockchain and look at the NFT associated with this artwork, you'll see that it has his digital signature, in the sense that it was actually transferred from his Ethereum address over to you. And he's a celebrity artist. He's not just an everyday person that no one knows, right? So he's a special celebrity artist with quite a few followers in the millions on Instagram and on social media. So when an artist with that reputation signs an NFT and transfers it from his Ethereum address, his or her Ethereum address to yours, then that is what gives the token that you hold the uniqueness, because it's authorized by this artist and it's also signed, and it comes from their unique Ethereum or blockchain address that you got the painting from. So the value, I really would argue, is coming from there. It's not really about a specific digital file. And something similar can be said about one of these CryptoKitties as well. So like I said, it's there's only one cat with these attributes that is stored on the blockchain, and it has a unique ID. So I can't quite find another cat with this sort of a dragon tail. I think this particular cat is unique because it has a special tail that looks like the tail of a dragon. So there's only one such token representing this particular cat on the blockchain, and that's really why it is scarce, right? So the scarcity is not in terms of how many copies of the file you can make. It's about how many NFTs exist that point to this overall idea of this particular asset or artwork, and that hopefully would resolve a little bit of our I'd say sometimes our misconception about what exactly is being sold here and what exactly has this kind of staggering value in terms of hundreds or thousands of dollars. A way to demonstrate this would be to go over to another of Beeple's artwork. So this is again owned by Beeple, the celebrity digital artist, and this is called the 5,000 Day Selects. It's basically an NFT that's owned currently by a different person. So I think it was already sold by Beeple to Samiha, who's the new owner of this NFT. But what you'll notice here is that you can trace it back to Beeple's original Ethereum address. And that instantly gives this token uh, the legitimacy and the celebrity status that someone would want to own this token for. Um, I mean, I could have made a copy of this token and minted it as an NFT, but had I done that, um, if someone went back to the blockchain and looked at where that token came from, they'd see that it's not coming from this address, right? It would be coming from my Ethereum address, and I'm not really a celebrity on the in the digital art world. So a copy of the token that I create won't really be valued as highly by the market. However, where you can establish that this token is owned by this unique address that belongs to Beeple, and that's public information. We all know what Beeple's unique Ethereum address is. It's verifiable from multiple sources online, and that's what gives it sort of the legitimacy and thereby its high valuation in the market. So yes, hopefully that shares a bit of insight into what exactly is being bought and sold. Now, the purpose of this slide is to give you some examples of popular NFT marketplaces. So obviously, if you do a couple of Google searches, you'll probably end up with these and more. But if you haven't been to an NFT marketplace before, then this might be a good place to start. So these are some of the most common, most popular ones. So if I were to click on one of these, you just get a sense of what these marketplaces look like, right? So these are the top sellers who sold NFTs today, and these are NFTs which are currently listed for auction, right? So these are what look like digital creations by artists on the internet, and then they've sort of listed these items for sale. So you can always go here, bid for these NFTs, buy and sell them, and add them to your collection. So most marketplaces look, kind of like this. So obviously they would have different layouts and different look and feel, but the general principle is the same. You'd have a set of sellers, you'd have a number of NFTs for sale, and then there'd be some options that enable you to create NFTs, sell NFTs, bid for NFTs, and so on. So I would definitely encourage you to go click on some of these links, take a look at what these marketplaces look like. This slide explores how we can participate in the space. So again, this is not financial advice, certainly not suggesting that you should go and do any of these things, but these are different avenues available if you want to explore and participate in the world of NFTs. So the first is as a creator. So we looked at this briefly, right? So if you're an artist, musician, writer, etc., so you can turn one of your works into an NFT. And I think this serves multiple purposes. One is, of course, that if you have some sort of a following, or if you're a bit of a celebrity, then you can certainly auction off NFTs related to this work, or you could also use it to establish that you created a piece of work at a certain point in time. So, for example, if you've created a new song, you could make an NFT out of it, put it on the blockchain, and then it would be evidence that you came up with this song on a certain date, because that entry would become a permanent record in time. Another advantage of this is that you can include recurring royalties. So the way this works is every time your NFT is bought or sold, you would get a certain predefined percentage as a cut from that sale. So it's not just about making a sale once, but it could become a recurring revenue stream for you every time your creation changes hands. So the smart contract can be set up to release something like, let's say, 5 or 10% of the value into your account. The second option is to participate as a collector. So if you're a collector, you can then expand your collecting into the NFT world. You can collect and hold different kinds of NFTs. You can then trade them, display them, or just basically organize whatever you would with a regular collection, but now with the NFTs in the digital space. The third is as an investor. So here it could be in terms of buying and selling collectibles, right? So you can buy and hold collectibles, sell them when they're in higher demand or when the price goes up. Pretty much related to what we looked at in point 2, but more as a commercial buyer and seller of collectibles. The other option is to buy and sell tokens related to NFT based blockchains or marketplaces. So, for example, Rarible.com, which is one of the websites that we looked at earlier, it has its own token called Rari, which is traded on cryptocurrency exchanges. So, when there's an increase in NFT activity, there is likely to be a higher demand for tokens where NFT buying and selling is on the rise on a certain marketplace. So if there's a lot of buying and selling going on Rarible.com, there could be an increased demand for the Rari token. So that could be one way where you buy and hold that token and then sell it at a future point of time, or just hold it as an appreciating asset if a certain marketplace is doing really well. The third option within investing is to buy or sell the base currency of the blockchain where the NFT tokens are being traded. So Ethereum would be a good example of that. So when there's a lot of excitement about NFTs, then there is an associated increased demand for Ethereum, because every time you mint an NFT, you buy or sell an NFT, there is some transaction that's happening using Ether. So there's an increased demand there, therefore, for the Ether currency. So that could be another way where you could look at investing in the base currency of the blockchain, which supports NFTs. The fourth item is just very open. So I'm saying it's entrepreneurship in terms of creating some sort of a new marketplace, for example, like what Rarible does. It facilitates buyers, sellers, creators to sort of come join a certain platform and then engage in these marketplace type activities. Or in general, you could look at creating some sort of an NFT enabler, right? So you could create a website that helps people accomplish something using NFTs, right? So if you understand how they work, you understand how these smart contracts work, you could then use that knowledge to build something in the NFT space in the form of a product or a website or a marketplace. And in general, again, the emphasis is that this is a very new space. So there's a lot of room to think about new use cases, to think about new ways of leveraging this functionality to build a new product or some sort of a revenue generating item. So again, it's worth thinking about, right? So with a fundamental understanding of what this is and how it works, there's definitely a number of different things that can be done, and this is just the beginning. It just started in 2016, 2017. So if you hit upon some interesting idea now, it could be pretty big in 5 years time or in a few years time from now. So definitely worth exploring more. All right, so we're now at part 3, which is all about creating an NFT. So I'm going to walk you through the steps that you can follow to mint your own NFT. So we'll head to Rarible.com, which is the website that we'll use as the example. So the first step is you click on the right-hand side corner and link your Ethereum wallet to the Rarible site. And once you've done that, it will show your unique Ethereum ID over here. So now, if you're not familiar with what an Ethereum wallet is and how it works, it's really simple. I'd suggest look it up online, watch some YouTube videos on how to create your own Ethereum wallet. But what it essentially is just an app. You can go to your Android Play Store or the Apple Store and download a number of different apps that support cryptocurrency transactions and wallets. So once you downloaded that app, it will let you create your unique Ethereum address. And once you're done with that, you can then use that wallet to link to this website. And the way it works is when you click on this, it'll prompt you a couple of options. It'll give you a few options on which wallets you can connect. It'll give you a QR code. So if you scan that QR code using your mobile phone, once you're inside the wallet app that you just downloaded, it would instantly link it to the site and show you the public address. So that's secure. There's no problem there because this is your public key. It's not your private key. Your private key still resides inside your wallet. So all you have to do is scan the QR code, and your public address would end up here. Now, to actually perform the transaction, you have to sign the transaction with your private key, and that's pretty easy too. So when you perform certain actions on this website, once you've linked your wallet, the website will push notifications directly to your wallet on your mobile wallet app, and then you'd have to just hit yes or no to approve or reject the transaction. So it's really that simple. It's a matter of just getting over that one initial hurdle in terms of getting a wallet app on your phone. Now, once you've done that and you've connected your wallet to this website, you would then hit on create, which lets you create an NFT. So there's an option. Do you want to create one single NFT, or do you want to mint one NFT and then sell it multiple times, in which case you want multiple NFTs? So let's go with single. I'll say start from scratch. The first step is to choose a file. It could be any digital file. It could be a piece of music, like an MP3. It could be a video, MP4. It could be a picture. It doesn't show JPEG here, but JPEG is supported as well, and we'll be using a JPEG as an example for this video. So I'm going to select this file, which is the poster of the original talk that I gave, not this one, but a week or so back. This presentation was actually given as a Zoom talk, and this is the poster that invited people to that talk. So I'm going to say put on sale. I'm pretty sure no one's going to bid for it, but we were just demonstrating how this works, right? So when you click on, or maybe they will, maybe someone would be interested in coming and bidding for this poster. So when you click on put on sale, it when it generates the contract, it knows that it's going to make this poster available for auction, right? And then when you click on this, it lets you specify a price, but I'm not going to do that. I'm just going to leave it as a bid. Now, the next step really is, so I'm not very sure what this unlock once purchased is. I think it's just a matter of allowing some digital key code to redeem or to link to a file. Yeah, not too sure about that, but that's not terribly important just now. I'm sure you can adjust some of these settings in the future. For example, once you've minted the NFT, you can always take it off sale if you wanted to. And I don't think this hard codes anything into the contract, as far as I know, at least these three options, because the price and things like that can be changed and updated later on. All right, so next step is to then mint it either as a standard ERC-721 token or as a rareable token. So there's not much of a difference between the two, other than the fact that when you mint it through rareable, they will have used the 721 contract, but on top of it, they'd add some additional functions that are supported by the rareable ecosystem. So when you click on this, you get that additional functionality. So I'm going to say my first NFT, and give it a description. Right. Then you can indicate some sort of a percentage that would go as a royalty every time this NFT is bought or sold. So that's the royalty that I was talking about earlier. And I don't think these are necessary, so we'll skip that. Now, what happens when you click on create is it pretty much generates a couple of notifications to your wallet. So where it says pushed a request to your wallet. And the reason why this works is because my mobile wallet is connected to the website. So on the wallet, I would have to click yes. And if I do that, then it calls this contract and essentially mints the NFT or creates the NFT. Once I'm done with that, it would push another notification to my wallet to sign this transaction. So when I do that, again, a message would go from my wallet, which is a signature. It would go to the website, and then it would create the token and generate a sign order that authorizes this NFT to be sold. So I'm not actually going through these two steps just now, but that's pretty much it. There's no other steps. Like once you click on yes and click on sign order, it's done. And the reason I'm not going through this right now is because the gas fees are really high, and I have no particular need to mint this NFT just now. However, I just completed those two steps previously, and when I go to my items, you'll see that the same poster that I was trying to mint just now was created as an NFT a few days ago. And then there's a couple of other NFTs that I minted and listed here. So it's really that simple. It's like uploading a file onto a website and making a payment, and that's it. And then just a couple of choices in terms of whether you want to create one or multiple items, and that pretty much creates and lists an NFT on this marketplace, and it shows you that I'm the owner of this NFT. It says that 10% of sales will go to the creator, and it doesn't really have more owners here. If this had been bought by someone else or transferred to someone else, then you would have seen the names of those owners and the history of all transactions associated with those owners. Now, what we'll do is to understand how that traceability actually works. We'll pick an NFT that's been through some of these steps where it's been minted first and then transferred to a couple of people where the ownership changed hands. So we'll get a view of how that traceability can be looked at on the blockchain. But for now, these are the steps that you'd follow to actually mint an NFT. So it's really simple. Feel free to go online and attempt minting one of your own NFTs. If you have your own creation, a photograph, a piece of music, this works really well. But even if you aren't really a creator, you can certainly use an existing image to attempt to mint an NFT out of it. All right, so hopefully that gave you an understanding of how easy it is to actually create an NFT and launch it on the Ethereum blockchain. All right, so here's an example of how these NFTs look like in your mobile wallet. So this is a screenshot of my wallet, which shows, this was one of the pictures you might have seen on the previous screen where I'd minted this as an NFT. Similarly, these are the 3 crypto kitties that I own. So this is how they display within my Coinbase wallet. And you can then select these and transfer them to someone else or list them for auction and so on. Right. So again, this is a series of links to show how these NFTs look like on the blockchain. So let's probably use the crypto kitties as the example, right? So these are the 3 kitties, and actually created a new baby kitty by breeding these 2 cats, the dad and the mom kitty. So when I click on this link, which is one of those cats, so you'll see that this is one of them, right? And if I flip back, you'll see that that's one of the kitties that I own, right? So you can validate that on Etherscan in terms of the traceability of this cat. So if I were to go down and look at the contract that created this token, you'll see that it has a unique token ID. So there's only one cat with the number 1148589 on the Ethereum blockchain. So there's, and that's this particular cat, right? So similarly, for the other cats here, you can see again, its unique token ID that was basically associated with the second cat, and likewise with the new baby kitty as well. Now, for the new baby kitty, the input data that went in to creating the baby kitty was the mom and the dad cats. So the unique ID of the matron, which is the mom, and the sir, which is the dad, are listed here, right? So it keeps track of which two specific cats were used to create this third baby cat, right? So basically each cat has its own unique NFT, and there's a trail of how this cat came into existence on the blockchain by breeding these two other cats. So it's a fun game. You should definitely look into playing it. It's got a lot of interesting attributes in terms of how these cats have different features, as well as and then breeding these cats so that when a new cat is born, you automatically become the owner of that new cat on the blockchain. Okay, right. So this slide aims to show traceability in a bit more detail. So I'm clicking on this link, which takes me to a particular user on Rarible who minted this NFT called the Lion, right? So it's a picture of Elon Musk. Now, if you look at the owners, it shows you a number of different owners of this NFT, right? So the reason for that is he minted 25 of these tokens. So and if I sort of go to one of these owners, or actually this is the guy who created the tokens. If I think I'm already on his profile. Okay, right. So what this shows is these are the people who bought a number of these 25 tokens, right? So a total of 25 was created. These are the owners, and then if you look at the history, it shows you when each token was transferred to these buyers, right? So the very first transaction here is the one where 25 tokens were actually minted, right? Put on sale 25 editions for 0.1 Ethereum each. These were minted by this person called the Lion. And then once he minted these 25 tokens, he listed them on sale. And then these buyers basically came in and purchased all of these tokens. So if I go back to the link here, it shows you the history of this token on the auction website. So if I sort of scroll down here, this is the complete history, right? It shows when this token was created first. There were 25 of them. And I could, again, go to Etherscan and look at the actual contract and the corresponding transaction. So when I decode this data, this is the data that went into the contract. So this is the unique token ID of that particular token. And it tells you how many were created. There were 25 which were created. And this is the contract that created these 25 tokens, right? So this is what you'll also see here is that these tokens were basically minted from scratch, right? So where that can be established is you'll see that these 25 tokens will have been transferred from a null address, which pretty much means that they didn't exist before, right? They're being created for the first time, and transferred to the owner of this particular contract when he initiated this contract. So when you see this from address, it ends in 165A. So just bear that in mind. And if I were to then go back to this user, the lion, actually, I'll look at it on OpenSea. And the name of this user is the lion. So when I click on his address, you'll see that it's the same address. It's the one that ends in 54D165A, which is what we saw on Etherscan as well. So if I were to then head back to Etherscan, it's the same address. Which is 54D165A. So it means that this contract was initiated by this particular user, and this contract was invoked, and that resulted in the minting of these NFTs. And you can see that the function that's called here is mint, which basically creates this NFT from scratch. Now, if you were to go back and look at the rest of the history, so this was when 25 NFTs were minted. And then if you look at the first transfer, when he transferred this from his own address to this new address, which is board Elon Musk. Again, this can be established as well by looking at Etherscan, where this time it's not a mint, but it's actually a safe transfer function, which is basically transferring this NFT from one person to the next. So in this case, he's transferring it from his own address and into the buyer of this NFT. And again, the unique token ID is listed here. So this shows how traceable all of this is. It shows that right from the time this token was created, which is right here, and it shows that it was created from a null address. It didn't exist before. It was created for the first time and transferred to the owner. And then subsequently, this owner then transferred it to other people. So as it changes hands and people buy it and sell it, there's a record of every single transfer that gets recorded on the blockchain. And that basically makes this whole process really traceable and secure. All right, so that brings us to the end of the presentation. So obviously there's no Q&A because I'm just recording this to share on platforms like YouTube and so on. However, I hope this served as a good introductory session on NFTs. So just to recap, we looked at what blockchains are. We looked at what tokenization is. We looked at what fungible and non-fungible mean, and why we need the concept of something like a non-fungible token. And then with that understanding, we then further explored what types of use cases are common, popular across today's NFT market. We looked at some examples of some NFTs that sold for some pretty staggering prices, right? And we understood the notion of what actually is being bought and sold. Is it the file? Is it the idea behind the file, authorized by the creator, and so on? We also looked at different ways in which we can engage in the space, given our different backgrounds, our different interests, and so on. And finally, we looked at how easy it is to mint a new NFT. And we also looked at examples of how that NFT can be traced across the blockchain in a very reliable sort of a way, where you have a complete track of the point when it was created through to its entire lifetime of where it transferred from one person to another. Right. So hopefully this gives you a good introduction of NFTs. So keep exploring, keep learning, and do come back and attend more events and sessions with the Crypto Cooperative. All right. So with that said, thank you all. And this brings us to the end of the session. Bye.